So an ecosystems can change. After a forest fire, ecosystem is decimated, and it takes decades, a century, for a forest to come back in its original form. And rather than just focusing in on the plants, there's a whole ecosystem that's supported there in terms of plants and insects and animals, as well as the things in the ground as well. But the whole ecosystem is diminished, far fewer species there than before. And what's occurred is, over the last 15 years, an understanding that in a number of disease states, there's a profound alteration in the microbiome in these different disease states. Now, this has been helped greatly, this understanding, because of developments in molecular biology as well as developments in computational science. In molecular biology, instead of having to culture microorganisms, there's a way of using techniques where you identify the 16S ribosome that's very specific for bacterial species, so you don't have to culture microorganisms any longer. And as a result, you can rapidly identify the number of species in a sample, and it allows you to have a greater understanding of the distribution of species within the microbiome. But what you see on this diagram at the top is a microbiome that's healthy. You have a diversity, you have abundance of microbiota. Their principal phylum are firmicutes and bacteroides and acinetobacter. They produce a number of products such as healthy levels of short-chain fatty acids, which occurs as a result of eating a diet that's high in fruit and vegetables. And then in this upper level, you see an intact epithelial layer, and there's no overt inflammation. Now, with a dysbiotic circumstance where you have an alteration in the microbiome, that has been associated with changes not only in terms of the bacterial population, but the epithelium itself changes. With reduction in bacteria that produce short-chain fatty acids, you have less stimulation to the epithelium. It doesn't produce as much mucus. More bacteria can come in contact with the epithelial surface, leading to more inflammation, more ingress of bacteria, and as well as various proteins that can stimulate inflammation. And as I mentioned, when this inflammation occurs, it does not remain local. It circulates systemically. So over time, the concept of a human intestinal permeability has arisen. Now, this has been taken up by the alternative and complementary medicine community and designated the leaky gut. You cannot talk to someone in this community without bringing up the leaky gut in about 10 seconds. And everything is blamed on the leaky gut. And the basis of this is this normal permeability that occurs across the gut epithelium. Normally, there is some level of permeability. In an inflammatory state, that permeability increases. On the left, you see various items such as fiber, glutamine, vitamin D, cysteine that help in terms of maintaining a normal epithelium. On the right, various items such as gliadin in the context of celiac disease, direct alphanol, changes in bile acids can affect the mucin. An interesting one recently is the idea of emulsifiers and how it can affect the gut epithelium. And I just want to digress for a moment. Emulsifiers in food, that became widespread about 50 years ago. That's what gives processed food its smooth texture. It allows you to be able to emulsify food so you can taste it better and it feels better in your mouth. Think of pudding, or think of ice cream, or think of any kind of processed food. That's where emulsifiers play. But the emulsifiers in those food don't just stay in the food. They're not digested. They arrive down in the lower GI tract, and they emulsify the mucus layer, allowing greater contact with the microbiome, and that has been, at least in mouse models, associated with greater inflammation. So I only mentioned the human intestinal permeability is not necessarily being the end-all of causing inflammation, but it just so that you understand the concept of that quote-unquote leaky gut. Now, there are stressors on this permeability. obvious ones such as mucosal disease, like I mentioned, celiac disease, inflammatory bowel disease. Interestingly, although endurance exercise is viewed as a quote-unquote healthy, these elite marathons, these ultra-marathoners, when you exert yourself to that degree, there's a tremendous diversion of GI blood flow away from the GI tract. And over a prolonged period of time, more than 2 hours, you can start to get ischemia of the GI tract, and you can get mucosal damage as a consequence. So it's not reported because it's not very popular, but the individuals that run marathons frequently afterwards, they'll have melenic stools. They'll even have diarrhea during the episode. There was one famous instance of the New York Marathon where they're focusing on a runner, this female runner, and they would just say, oh, there's something wrong with her leg. There's something wrong with her leg. She's in the lead. Well, she was wiping off poo off her leg the whole time because she was having uncontrolled diarrhea during the running of the race. And that occurs as a result of the ischemia that develops. You're not able to absorb fluid as readily, and you can develop diarrhea as a consequence. Burns, non-steroidals, other things, chronic liver disease can also affect permeability. Now, what I wanted to focus on now is not so much the permeability, but the microbiome. Now, Eli Michnikov, a microbiologist from 1907, won the Nobel Prize, advocated that changes in food intake that can influence the intestinal microbes, and that looking at the foods that we eat can potentially lead to a more favorable distribution of microbes that are favorable for human health, and that could potentially even eating certain food items such as yogurt may introduce microorganisms that can be beneficial. And the more formal definition of a probiotic now is microorganisms that provide health benefits to the host when consumed, but these microorganisms are not necessarily a normal constituent of the microbiome and require oral supplementation in order to be maintained. Now that contrasts to the concept of fecal microbiota transplantation, or FMT, that's easier to say, which is involving the transplantation of a microbiome from a healthy person into another person. Now over the last 15, 20 years, the history of FMT has been associated with greater understanding that in a number of disease states, there's an alteration in the microbiome. And we see in the upper left, this slide is from 2013, a number of conditions associated with an altered microbiome: multiple sclerosis, chronic fatigue syndrome, non-alcoholic steatohepatitis, obesity, and then atherosclerotic disease. In terms of the pancreas there, individuals with metabolic syndrome. And then in the lower right, what we'll be focusing on is Clostridia difficile, irritable bowel syndrome, and inflammatory bowel disease. So I want to digress for a moment to give you a little background as far as the history of FMT. Now, the Chinese journals, I don't subscribe to them, but in the 4th century, it was first reported the use of using a fecal suspension for treating individuals with intense diarrheal illnesses. And then this was evolved in the 16th century in China, where they're using fermented fecal material, fresh fecal suspension, dry feces, or infant feces for treating intense episodes of abdominal pain, fever, and vomiting, and diarrhea, and it was designated yellow dragon soup. That never got real popularity subsequent to the 16th century, but it was picked up by veterinary scientists who in the 17th century developed the concept of transfaunation. That is to say, the transfer of cecal contents of fresh stool from healthy horses to treat horses with a chronic diarrheal illness. And it was very successful. And similarly, in rumen transfaunation, it was used to refaunate cows that had been off feed because of mastitis or illness. Now, just to refamiliarize yourself with the anatomy of cows, they have 4 stomachs, and each of these, you don't have to know the names, there's no test on this, but there are 4 stomachs, each leading to the next, which lead to fermentation of material. And in order for them to degrade the foods they eat, it requires this fermentation to occur. And if they're off feed or off food for a time, to diminish milk production, to minimize mastitis, then that bacterial population can diminish. And so it was found that if you could refaunate, that is to say, reintroduce these microorganisms into their stomachs, and they would help them in terms of being able to gain weight once more. This fermentation of food is very efficient for them, but it leads to production of terrific amounts of methane, which they burp all day long, up to 500 liters a day. So it's kind of remarkable production.